So welcome everyone to this talk titled Beyond JavaScript Frameworks, Making Reliable Web Apps with Elm. So how many of you know who Jonathan Ive is? Hands up. Quite a few. So Jonathan Ive is the Chief Design Officer at Apple. A very critical person in the development of all the recent major Apple projects. So this is my favorite quote about Elm. It was made by one of my colleagues, explaining Elm to a fellow graphical designer. So Elm is like Jonathan Ive made a programming language. It is minimalistic, it is user-friendly, and it just works. So of course this is a little bit biased, but I think that in a way it kind of captures Elm. So my goal for the next hour is to explain why I think this quote is so great and why Elm is great. So I'm going to do this through a two-part agenda. First I'm going to share with you how Elm works, and how you build apps with it, and why I think it has such a great potential. And finally, I'm going to share a little bit about Elm in Norway, the Elm community, and who is using Elm, and what are they using it for, and what are their experiences. So I guess it's about time to introduce myself. My name is Erik. I work at a place in Oslo called Beck Consulting, a rather large consultancy with about 400 people. And I specialize in JavaScript and large SPAs. So pretty much for the entirety of my career, I've been working with large single-page apps, both with JavaScript and the design part. And working with JavaScript is real fun because it's so flexible, right? You can do basically everything. So how many of you would say that you are pretty good at JavaScript? So that's maybe about half, or between a third and a half. So I guess you can tell me what this is. So you could take this and paste into your JavaScript console, and it would print out something. It could be. It's a good guess, but it's not. It's hello NDC. So it's actually possible to deduce it if you learn the rules of how this crazy thing works. So I thought I'd just start a talk by taking you through this little detour of how beautiful and crazy JavaScript really is. So I'm going to give myself an assignment. We're going to create the letter E, which I think is a brilliant letter. It's the most frequent letter of the English language. And it's also the first letter in my name, so I like it. So it's about time for a little demo. So I'm only going to use 6 letters. I'm going to use the, how they called, the angle brackets, like these ones, and the parents, and the plus, and the exclamation mark. So in JavaScript, I just love working with arrays, because arrays are so flexible, just as like the language itself. They're actually objects and not the proper array type. So you can do a lot of cool stuff with them. You could take an array and coerce it into a Boolean value. So it would have to be either a true or a false. And if we negated an array, it would do just that and become false, because an array is true if you try to get truthiness out of it. So you could do that again, and we'd have a pretty short word that contains the letter E. So we are approaching our goal. But we'd need that to be a string. And as everyone knows, summing arrays together yields an empty string. So we could just take the truthy value, sum it with an array, and boom, there we have our E as a string, in a string. And as you can take strings like this and fetch out a single letter based on their index, we can basically do this. But now we're cheating. We can't use the letter 3, so we have to create that somehow. Okay, so back to our arrays. Let's try to do arithmetic with our array. Let's do plus array, 0. And but 0 doesn't help us in obtaining a 3, so we'd have to get a 1. So let's go back to coercing it into a Boolean value, because 0, that's basically true if you negate it, right? And then we can take true and turn that back into a number. Voila. And now we just have to do this a couple of times. Then we got 3. And then we take this thing and try to extract that index from our little true creator over here. There we go. So it's not that many hoops you have to jump through to get it to work. I actually wanted to make something more complex, like NDC. But then we'd have to get a way to get a hold of the filter function on the array prototype, and then do a toString on that, and then fetch the C from the native code. So imagine that's index what, like index 15 or something. So my talk would have been mostly doing this. So what's the point of doing this JavaScript exercise? So it's hardly in use anymore. JavaScript is really wonky, and the type system is really bad or funny. But it's a fact that a lot of people still love JavaScript and build pretty amazing stuff with it. So JavaScript has been on top on Stack Overflow for many years. I'm not sure if it still is, but it has been. And on GitHub in terms of usage, presence at conferences, demand for new and shiny frameworks and tools, and innovation in the open source community has just been tremendous. So I mean, you have this jungle of JavaScript frameworks. So before I started using Elm, I was a big fan of React and Redux. And maybe with some TypeScript on top and immutable JS and Webpack and Babel, and the list is pretty long of tools. But I'm not sure if JavaScript is the best tool for writing single-page apps anymore. And I'm not sure if I'm convinced that TypeScript is the answer either, even though it's a lot better than JavaScript. Or Fable, or ClojureScript, or PureScript. The list is very long of alternatives. So some rhetorical questions for you. Did you ever ship a large SPA, being confident that it wouldn't crash in production, even though you didn't test it or put it through lots of QA? I know I didn't in 6 years of full-time JavaScript development. Did you ever refactor an SPA, confident you didn't break anything? Like, how do you do that? You just refactor the app, and you run it, and you hope you fix all the bugs in the console, and you just hope it works. You basically have to test every page, right? You have to run through all the code. Perhaps you were overwhelmed by the amount of stuff you need to learn to work with modern front-end. So I'm a practice lead for front-end development at my company, so I should be one of the ones the most updated on the JavaScript landscape. But I feel really stressed by just all the new stuff coming out. So JavaScript fatigue is a thing. And are everyone on your team really comfortable doing front-end tasks? Because in most of the teams I've been a part of, you have the people who are really comfortable with front-end, and you have the other people who are not. And that's always a pretty big group of the team. So for me, 7 years full-time front-end developer, check, 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 check. And I think this is a big problem. I mean, it's 2017, we have all these great tools, great languages, these great practices, but still this is like the de facto standard for a lot of people. So in my experience, Elm addresses all of these problems. So I'm going to show you how does Elm work, how do you build apps with it, and why do I think it has such great potential. So Elm is a language that compiles to JavaScript. So it's not a framework like Redux or Angular or Vue.js or all of these others. So it basically means that you write your app in Elm, you compile it to a JavaScript file, and then you just add that to your site, like this. Let's say you have a main.javascript, and in a script tag, you would just grab the global Elm object and grab your app called the main, and just embed that somewhere in your document. So it's pretty easy to use Elm on a part of your app, just like with React. So that's how Elm fits into your web stack. So looking at Elm at a glance, it compiles to JavaScript, as I said. It has an extreme focus on robustness and safety. That means it shouldn't be able to crash. So there's a famous Elm quote saying no runtime errors, like your code will not crash runtime. And it's an ML family language, so it's similar to Haskell. That's the main inspiration, even though it's a lot simpler than Haskell. But it also resembles OCaml, or maybe the most interesting language at this conference, F#. And user friendliness, where the user is us, developers, is a big priority in Elm. And it's extremely opinionated. It sets all sorts of, it really is just really opinionated. So for a lot of people, that's a big turnoff. Some of the main notable Elm language features is that all data is immutable. It's an expression-oriented language, so there's no statements. And it's pure, so all side effects, like fetching something from the server or generating a random number, is handled by the runtime. So you don't have to do that dirty code yourself. You just say to Elm, hey, please do this for me, and you'll get the data back, or a failure. And architecture is a feature in the language. You don't have to pick, should I use Elm Redux or Elm Angular or Elm Reactive something? You just use the Elm architecture. That choice has been made for you. And it has a pretty small but expressive feature set, like Lego blocks that just click together. But it's a lot smaller in terms of features than, let's say, Haskell, or perhaps even F#. So let's have a quick look at the language. So as a functional language, functions are at the core of the language. So this is a very simple example function called increment that takes one argument named x, and we just return x plus 1. And 5 is a constant. I would say the variable in JavaScript, but it can't change, so it's a constant. That's the result of calling the increment function with the number 4. And Elm has full type inference, so it knows, it can infer all the types in your app. So since you are adding x to 1 with the addition, the arithmetic addition operator, it knows that x must be something that handles that, and that's just numbers, so it has to be a number. But of course, you could specify the type signatures yourself, and you should do that because it's great documentations for other people who read your code. And also, it allows the compiler to tell you that, hey, you intended this function to do this, but now it does this instead. So maybe you did something wrong. So we have constants, but we also have tuples, which is basically like a fixed length array that can have values of different types, like a pair of ints. And also, we can have records, which are an equivalent of JavaScript objects, just a collection of key value pairs, basically. And please note that all the type signatures have to be on the line directly above the declaration. So these are the basic building blocks. But let's say we want to say that a person or a customer has a certain shape. We could use a type alias, which is a way to introduce new types into our system. So we could say that coordinates, that's basically whenever we have a pair of ints. So they are totally interchangeable. It's not like a class or a constructor or something. You can just say that whenever we have a pair of ints, you could interchange the type signature with coordinates. Same thing with discount. You can just say that whenever we have an int, it's basically a discount as well. So it could make your code easier to read in some cases. But it really becomes interesting when you use this with records. So you could say that a customer has this shape, and you can make a customer with name and age. Let's say a customer has a type. You have 3 types of customers. You have students, you have corporate customers, and you have private customers. So we'd make a type field. Let's say we were doing this in JavaScript. We would make that stringly typed. You would represent that as a string. And then every student have a student discount, which is a number between 0 and 100. So let's say when I was a student, I had a student discount of 50% at some shop. But then I started working at Beck, and I changed into a corporate customer. So now my student discount is 0. I can't just not have it there. I need to have a student discount, so it needs to be 0. So it's kind of misleading. It has to be there, but we would like it to not be there. So we have a couple of problems. We get empty fields with dummy values. It's very easy to mistype the type field. Let's say you write student without a T. There's no help. And also no help from the compiler. If you have some function that accepts that type, it wouldn't know that the only 3 possible values were those 3. So we need something that resembles an enum in C#. So that's where algebraic data types, or union types as we call them in Elm, come in. This is really one of my favorite features because it's so great at modeling the domain. Whenever I write ordinary JavaScript now or Java, I always keep reaching for these kind of constructions. So it's similar to an enum where you have a type that has a finite set of possible values. So the customer type can only be of student, corporate, or private value. But they are not singletons. They can be, you can create instances of these. And this is where the real magic happens. The different branches of a union type can contain different data. So let's say you have a student, and then you can say that in order to make a student value of type customer type, you would need to pass in an int. So student is basically a function or a constructor that takes an int. Similarly, with the corporate value, you will need to pass it a string in order to make a value of that type. So the compiler and type system will ensure that whenever you have a student value, you know it will have an int. So it's a bit like enums on steroids, I would say. So in order to unwrap these in the other end, you would use what we call pattern matching, which is basically like a fancy switch case. So you can just write case and then a pointer to some sort of constant of, and all of the different possible values for that type. So you can do this also for arrays or other types, but it's we would basically be able to extract the value that the union type is carrying. So for students, that means an int, the discount. And for corporate values, that means the string, the name. And we can name this whatever we want in this case, because the system will know what kind of type it is. And also, if you forget a branch, the compiler will tell you and just refuse to compile your code. And this is also used when you do something like a network call. Then the compiler will be able to tell you if you forgot to handle a case where the call failed, right? In JavaScript, forgetting to add the .fail callback is just so easy. Here, the compiler will make sure that didn't happen. So this is really, it's hard to overstate how important this mechanic is for modeling your domain. I currently work for the Norwegian railway company, NSB, and a ticket is just not a ticket. Like, there are so many different kinds of tickets, and they are all really different. I spent months and months trying to wrap my head around the domain model. And having union types would just help out so much. So let's say a ticket is either a single ticket, a return ticket, a period ticket, a tram ticket, or a zone ticket. There's even more, but I omitted them for clarity. And every one of them would carry a certain set of data, right? Then you can say that in order to make a single ticket instance, you would have to give it a single ticket data record. And then you would know that whenever you were handling a case where you had a single ticket, you knew that it would have these fields, and they would be populated. None of them would be null, because you don't have null, and you're home free. Our current JavaScript or JSON objects representing these tickets are just a mile long with lots of null and undefineds. So the way we can get rid of null is by having an optional type. So it's called maybe in Elm, and you use it whenever you have something that could have a value, but it could also just be nothing, basically. So a maybe is either just something or nothing. And A is here representing a type placeholder or type variable, meaning any type. So let's say you're making a game, and whenever you are having the first playthrough, you wouldn't have a high score until your game session ended. So then you would have a maybe int, or maybe high score. And you would, again, just use pattern matching to make sure you knew what to do in the case of it being just a high score or nothing. And you have several kinds of these constructs. You also have a task, which is something that can fail, like a network call, or trying to fetch the first element in the list because the list could be empty, etc. So again, the compiler has your back, and that's pretty much the tagline of Elm. So when it comes to putting an application together, you have what's called the Elm architecture. And this is actually the inspiration for Redux, the hugely popular JavaScript library created a couple of years ago by this guy called Dan Abramov. He fooled around with Elm and thought it was so cool, and he was thinking, we need this in JavaScript. This is a great pattern. The only bad part is that you don't have the compiler making sure you're handling every case in JavaScript. You have to just make sure you hope you do that yourself. So this is the way the Elm architecture works. You need to have some app state, and that's typically done by creating a type alias that has all your data that we call model. And then you have the view function that knows how to represent that model as HTML. So it's basically a function from model to HTML. And that HTML may emit some events, like if the user clicks on a button or interacts with an input field, you need to know what kind of type does that event have. So that's the deal so that's the story of HTML message. And a message is basically like a Redux action. It's an object that represents what happened in your application. Like user clicked on product button, user timed out, fetch user succeeded, etc., etc. Then you have the update function that defines how the model should be changed when something happens, basically. So it has a signature, it accepts a message, what happened, and what was the previous state of your application. And then finally, you should return the new state of your application. So if this reminds you of Redux, it's because it is, basically. And the final thing, subscriptions, is how you can tell the Elm architecture that you would like to subscribe to certain things, like a WebSocket, or notify me every 100 milliseconds because I'm updating my game loop, or notify me when the user has clicked any buttons on the keyboard, like globally on the page, etc. Sometimes you need to be able to interop with JavaScript. It's not very easy in Elm. I guess interop between F# and C# is a lot easier, and other compiled to JavaScript languages are a lot easier to interact with JS than Elm. And the reason for that is that JavaScript fails, right, all the time. So you basically don't want to interact with JavaScript, but hey, sometimes you need to. So we need to have the escape hatch. So that's done with something called ports, which is basically a message passing, like a pub sub system, where you pass strings to JavaScript and you get strings back. So the ecosystem is, of course, really microscopic compared to JavaScript. But it's growing, and I personally haven't felt that it didn't have anything that I needed at the time, like a component or some sort of functionality. But there are some good parts about the ecosystem as well, because since it is a strongly and statically typed language, you can do a lot of cool things. Like you can enforce semantic versioning. The first release of a library has to be 1.0.0, and whenever you change your public API, the Elm package module will enforce that you actually bump your major version. Similarly, it can enforce that you have documentation for all your public-facing functions, and packages cannot use ports, because ports can fail. So if you use a third-party package, you know that the package will function, basically. Again, there's this huge focus on correctness, robustness. So I'm going to implement a small app for you to show the IDE, the current tooling, how it works, basically. I'm going to create a counter app. Maybe not the most exciting application, but it's a good old one that I guess you have seen before. So I figured it would be good to just start with some code that doesn't compile. So here you have the error message from the compiler to the right in the browser, and we have Atom running displaying some Elm code to the left. The main function in Elm is what is outputted to the screen. So I'm trying to output a string, but the error message is saying that the main value has an unsupported type. So main only understands how to present HTML, SVG, or this magical program type, which is basically the Elm architecture. So I need to turn my string into one of these three. So let's use a text function. And that text function transforms my string to an HTML text node, which is of type HTML. So for our counter app, we will need some data, which is basically just a number. So let's start by creating the type alias model, which is just an int. So in every other app, model would typically be a large type alias with a record, lots of key value fields. And we could create a model and start it with just being 0. And notice when I save, the code is just moved around. And that's this lovely little tool called Elm Format, which is made by a third-party community member. And what it does is the same thing as Prettier in JavaScript. So Prettier was pretty much inspired by this tool. So it formats your code as per the recognized best practices and the shared conventions in Elm. So meaning that every time you save, your code looks like every other Elm code. It's formatted in the same way. And in the beginning, that might feel really awkward or frustrating, because maybe you wouldn't like your code to be formatted in this way. But there's a huge upside here, because every time you open a new Elm project, that project will look exactly the same as all the other projects that are using Elm format. And that's a pretty huge deal to me as a consultant working with different projects, different clients. Imagine opening an old code base that hasn't been worked with for a while, and everything's familiar, right? So there was this guy who Brian Hicks, he said that using Elm format is like having this robot butler following you around, like cleaning up your mess everywhere you go. And that's pretty much how it works. So let's try to print this number to the screen. So we'll have to toString it, which is a globally available method. There we go. And we could try to make a view function to present this instead. So the view function takes our model and returns an HTML with something. We currently don't have an event describing user interaction, so we'll just do this. And you see it's expecting me to actually implement the function, so I'll need to do that. So doing HTML in Elm is like doing HTML in React without using JSX. So every HTML element has a function that creates it for you. So you have the div function, the span function, the image function, the p function, etc. And they all have the same type signature. They take two lists, the first list being a list of attributes like ID, class, onClick, etc. And the second list being all the children inside that element. So let's start with a div with our text. There we go. And let's add some buttons to increment and decrement this number. So we can't just render the this one. Can't just render the plus letter in itself because we need to turn it into a text node, right? That's the first thing we did when we started coding. So if you're thinking that this formatting looks a little bit weird, it's because it is weird compared to JavaScript or many other languages. But it's based on what's the easiest to maintain and work with and read. Let's say I didn't want this line anymore. I could just delete it altogether and I didn't have to move the trailing comma and the line above. So I really had some hard time with this in the beginning. But after you just learn to accept it, it's really nice to work with. And Elm format just fixes it for you. So now we have two buttons. The next thing to do would be to specify what should happen when, or what are the things that can happen in our application. And that's modeled through a union type called message, which is basically just a convention. So in this app, you have either the increment thing that can happen, or you have decrement. And they don't need to wrap any data. They're just, you just need to know that, hey, this thing happened. You don't need to know that, hey, this thing happened with this data, right? So now we need our update function, which is the third part of a beginner program. So the update function takes a message, namely what happened, and it takes the old state, and you should return the new state. So here, Atom can just simply create the simplest thing that could possibly work for me, and I can just see that, it still compiles. So I know I didn't introduce any major breaking bugs. I could, of course, do some logical errors, but you know that all the building blocks just fit together. So here we use the pattern matching to basically switch on which event happened now. Was it the increment or the decrement? So this is a case expression. And I love doing this because Atom can, of course, know all the different possible values. So in a huge app with like, let's say 100 different messages, that's a pretty nice feature. So in the increment case, we would return model plus not 0, but 1. And in decrement branch, we would return model minus 1. So the only problem now is that we're still just displaying the view function one time, like hard-coded HTML. So here we need to use the Elm architecture, which has these 2 or 3 functions for us. It has a beginner program, which is what I showed you earlier. And it has the program, and it has a program with flags that allows you to do some input parameters when you boot your application. So we basically set our view function to be the view function, our model to be the model, and our update function to be the update. Still works. But we're not done yet, because we didn't add the onClick event handlers to our HTML. So now the event loop of Elm isn't being fired. So we have imported our onClick up here from the HTML events package. We just need to add it down here. So let's do that. So what we're doing instead of let's just keep it like that. So what we're doing instead of the JavaScript way of passing in a function and say, do this for me, we'd rather just say, notify me by triggering this kind of message, because that's more declarative. It's just, the view function isn't the right place to handle that you clicked on something. So the problem now is that our HTML is emitting an event. It may emit one of 2 events, like the increment value or the decrement value. But both of those have the type of message with a capital M. But we've stated in our type signature that it will emit whatever, because whenever it starts with a lowercase letter, it's just a type placeholder. So it could be anything. I could call it like, yeah, whatever basically. So we'll have to change that to message so that our app is totally type safe. There we go. So this pretty small example just illustrates the use of the type alias for representing the model and the union types for representing all the things that may happen in our application. The update function that actually changes the model whenever something happens. And then you have the view function to present your data. And of course, any real Elm app would be much more big than this one. So you basically compose it with functions, as you do in functional programming, and maybe your update function is divided into. You just move the different branches of your update function out into different files, basically. So there's this big 4,000-line real-world example of Elm made by Richard Feldman, one of the biggest, most famous people in Elm. That's freely available on GitHub. So I would encourage you to check that out if you want to see a bigger example of Elm. So let's go back to the slides.
Can I ask a question about that?
Yeah.
So do you find it kind of tedious with debugging because of all the vertical space that the formatter throws in, all the double blank lines and things that could have easily been on one line, make it so that this simple example would have been on one screen, but now you have to scroll up and down to see the code?
Yeah, I'll repeat the question. So the question was, does it bother me that there's a lot of blank lines introduced by Elm format when it could have been much more condensed, right? So no, in my opinion, it's not a problem. I'd rather have more sparse and more readable code than like really dense code. But I guess that's just a matter of personal opinion. So that's the way Elm works. It's very opinionated. So either you like it or you don't. But in my experience, if you embrace it, it gives you a lot of value, basically. So the only way to find out is just try it, I guess. So, of course, the obvious advantages of using Elm is the robustness and type safety. And it's so much easier to do large-scale refactorings. I mean, you could basically refactor a huge app and then just be pointed around your code base by the compiler. I guess we're all used to this by working with compiled languages on the back end, but on the front end, it really hasn't been like that for a long time. And to me, working with different projects, different clients, to just consolidate the architecture aspect and the reduction of the amount of frameworks you'll use. And formatting is a huge win. So you know that every code base will have pretty much the same layout, and both in terms of formatting, but also in terms of structure. Another thing I didn't point out is that you have the main function, which is the only thing that can render things to screen. But let's take your average JavaScript application. Every single line of that application could potentially touch the DOM, right? So you would never know. You could, in the bottom of, like in the smallest, most less important file, you could be doing some really bad stuff with your application. It'd be really hard to see. And the learning curve compared to other functional languages is, in my experience, really low. We did a workshop here, me and my colleague Ingar, this Monday. And I really feel it's a lot easier to learn than other functional languages. So it's a good gateway into the functional world. And since this is helped by the small but expressive language core, so they're doing some pretty tough decisions, the guy who writes Elm, to exclude very powerful abstractions that you have in Haskell and other languages, just to ensure it's relatively easy to learn. That being said, I think it's kind of funny that one of the biggest disadvantages is that the learning curve of FP is for some people still a bit tough. I mean, you can't just sit down and in 1 weeknight just grasp it. I think you can grasp Elm much faster than you can grasp JavaScript with React, with Redux, with TypeScript, with this and with that. But it's not like a framework you learn in a night. And another thing I'm a bit anxious to see the development of is the dictator-driven development of Elm. There's basically just one guy who made Elm, and he still has a pretty firm grip on the reins. I mean, there are other people helping out and doing commits in the compiler and such, but it's still pretty much him. His name is Evan, and he's calling all the shots. So still far, all the shots have been pretty good, in my opinion. But I mean, it's a bit of a risk compared to the open JavaScript world. And of course, you have the small but growing ecosystem. For some people, this is a showstopper. And for some other people, the small but expressive core of Elm is not expressive enough. They want type classes or higher counted types of, I don't know all their names, but like these Haskell heavy functional concepts that allow you to be a lot more expressive, but in turn makes the compiler errors so much worse and the language so much harder to learn. So Elm has been around for quite some time. It's been 5 years. It's been attracting a lot of attention and generating conference talks. I think I'm not overstating it when pretty much every conference these days have an Elm talk or Elm workshop. But is it really ready for production? Does anyone actually use Elm for their mission-critical user-facing apps? And if so, what are their stories? So this is something I wanted to ask myself, and I went out to try to answer this question. And the reason I'm able to answer that to some degree is that we wanted to really start building an Elm community last year. So through the Elm community, I've been meeting a lot of different people. So it's not like a scientific survey with qualitative data, and it might contain biased answers, but this is basically me talking to a large part of the Elm community in Oslo and Norway. So the Oslo Elm meetup is something we started last year. It has about 300 members now. We do monthly meetups where people do show and tells that are quite short and sweet, like 15, 20 minutes. And then the rest of the session is basically coding, meeting new people, asking people more experience with Elm than yourself for difficult questions you have, etc. Also, we started a conference this spring that was held this weekend, actually, because there was this conference called Elm Europe, and we invited like the biggest speaker from Elm Europe to come take a detour from Paris to Oslo to talk about Elm, and he said, yeah, sure, I'll do it. It's actually the same guy who made the real-world example, a real-world 4,000-line example, so he's a real experienced Elm developer. And we decided to, hey, what the heck, let's just do a conference. And we were actually able to gather 105 people in Oslo for discussing Elm. And that's when I really saw like the breadth of the Elm community. It really isn't like 10 people anymore. It really starts to be quite a community. So how most people are using Elm, they are following the guidelines from the Elm blog, which is basically, it's not rocket science, I guess. You just start small. Start with a small part of your app, perhaps the most difficult part of your app that has the most complex logic, that it's really well modeled in a language like this. And introduce that, and see how it works in your context, see how the team likes it, and then take it from there. If it doesn't work, it doesn't work. So I have this friend who helps organize JavaZone, the other big conference here in Oslo. And they had to redo their screens, like their info screens, and they have this special made software for that. And that software actually runs outside of this room right now. So NDC also adopted this app, and that's written in Elm. And the reason he wanted to do it in Elm was, of course, part of it is that he just wanted to check it out. I mean, most developers like testing out new technology, but also that 3,000 of his friends and colleagues would be watching that app while it was running. And it was written in old JavaScript framework, and he had really no clue how it worked. So writing it in Elm it seemed to make sense, robustness-wise. So it also has this backend where you can push slides directly to the info app, and that can be either a tweet or some text or a video or whatever, basically. So if something happens and like the bar opens 15 minutes later than it should have been doing, they just push a new slide to this app called Switcheroo. And there's also a lot of people at JavaZone who wanted to try Elm, also some more traditional backend developers who weren't familiar with like the modern JavaScript stack. So they heard, hey, there's a compiler and there's some types, hey, let's try it out. And suddenly there were some more people writing Elm that hadn't been writing single-page apps, basically ever. So that's another pretty cool thing about Elm, is that it enables more people to do pretty advanced front-end stuff. So they decided to do their call for papers or call for speakers app also in Elm. And that's being adopted by more and more conferences now. I don't think NDC is using it yet, but JavaZone is using it, and the Trondheim Developer Conference is using it. And I guess it's open source, so if you run a conference and you need a CFP software, just hit them up on Twitter. So maybe the biggest Elm adopter in Norway is this company in Bergen called Frende Forsikring, which is basically an insurance company. So they did this really thorough research on the state of the art in JavaScript. So they considered JavaScript with TypeScript and PureScript and Elm, ClojurScript, and they just decided that Elm would be the best fit for their stuff, or presumably the best fit. So they started small and just kept growing and growing. And before they knew it, they had re-implemented their entire app, basically. So they have said that we'll be writing all our new stuff in Elm, and they have about 10 developers writing Elm full-time or at least part-time. So they are really dedicated and are also hiring people that want you to work with Elm. And that's another dimension. So when you say that, hey, we use Elm, come to us if you want to write Elm. That's also something that should not be taken lightly, because I mean, you have all these developers who really feel really strongly about their languages, be it F# or Clojure or Haskell or Elm. And there's a chance your company might actually be able to hire some really talented people by being able to supply a job doing a language that's not very mainstream. Internally at Beck, we've been trying to use Elm at some like internal applications. So this is our find employee application, and we decided to do this one because it has a lot of things that could pose a challenge. Like you have this drop down, and you should be able to navigate a drop down with your arrows. And if you click outside of it, it has to be closed. So there we have like you're not clicking inside of a component, you're clicking outside of something, and then this something should close. So that's also a bit tricky to do, but it worked. And also you have the tags and labels that you can add inside of the search field. And of course you have like the availability stuff, that it should be navigatable by keyboard and by screen reader. So that's why we decided to tackle this beast. And we are pretty close to fully re-implementing it. And so far we've been able to overcome all of these kind of tricky challenges without any big problems. So it's a bit of a boring summary, I guess, but still it's pretty good to see that we didn't encounter any of these big roadblocks. So there's another consultancy in Oslo called Iterate. So they are doing a lot of like internal startups making products. So one of those is a site called Woolit, which is like a platform for people who like to knit clothes and people who like to wear knitted clothes. And they made this thing in Elm just to, like as a small project, just to test Elm and test the idea, of course. And there's another company called Blank making like a consultant marketplace for consultants. And they picked Elm for a very specific reason, because they knew that they didn't know what they wanted to build. They just knew that they wanted to build something in this space. So choosing Elm, they knew that they could do pretty safe refactors pretty fast while it's already in production without having to do a lot of QA. And another interesting thing is that their backend is in Haskell. But still, they didn't choose PureScript, which is pretty similar to Haskell. And the reason they chose Elm is because they also knew that they were having they were going to onboard some pretty new developers that from the university, and they wanted to check out if Elm would work in that context where you get like a week to fully learn Elm and then be productive. And what they found out is that actually this new employee was productive within a couple of days, like 2-3 days. And then, of course, those are long and intensive days learning Elm, but just having the confidence of the compiler and the type system is a pretty huge deal. So that's some of the things I want to highlight from the Norwegian Elm community. I know there's a lot of more companies experimenting building stuff, but like the biggest fish in the water is this American company, NoRed Inc. So that's where pretty much all of the internationally known Elm people work. And they also decided to hire the guy who wrote Elm. So it's a bit the same story as React and Facebook. So Elm has this semi-big company backing them. I know they have, I still thought they were like a 10-people startup in California, but this weekend I learned they have offices in like Sweden, Denmark, Germany, France, everywhere. So I guess they're getting quite big. But they have about 150,000 lines of Elm in production. So that's pretty huge. And they have open sourced a lot of nice libraries, and they're pretty much like a thought leader in the global Elm community. And they're also flying out their people to conferences like Oslo Elm Day for free to help share their stories. And I really feel that the Elm community, both in Norway but also globally, is really welcoming and easy to be a part of. So summary of those project experiences is that 100% of them would use it again for their purpose. Of course, there's some of them who have been holding back doing like even bigger stuff. So the things they've been building have been pretty safe, but it's nice to see that all of them would use it again. They didn't encounter any big roadblocks that would stop them. And the overall experiences are, of course, good, but mostly limited to those small projects. And they all pretty much report that of course, the safety stuff and the robustness stuff is pretty important, but also the onboarding and the developer experience and the team mobility, where traditional backend people suddenly enjoy writing front-end code, pretty complex front-end code. And the bad parts is, of course, the learning curve. If you haven't done any functional programming and you really don't want to learn functional programming, I guess there still is a learning curve. That was the biggest pain point in the State of Elm survey that was published a couple of weeks ago. And of course, if you have this huge React component library, you can't basically reuse any of that in a very easy manner because you can't call JavaScript code directly from Elm. So that can be a turn-off for some. And of course, if you are this really advanced functional programming user and you're used to Haskell and PureScript, etc., that may be a better choice for you if you know that your team will only consist of super awesome Haskell people, because you have no type classes and those kinds of heavy abstractions in Elm. So we released this tech radar with Beck a couple of weeks ago, and in this radar we put technologies in the adopt, assess, or withhold categories. And this year we have Elm in the use or adopt. So we think that use Elm if the team knows functional programming before or is open to learning, and app robustness or safe refactoring is important to you. And of course, the more complex the app is or your logic is, the better the use case for Elm. I might avoid Elm if speed trumps quality. Like if you're a startup and you just wanted to get features out into production as fast as possible, and just you wouldn't care implementing all the types and making your system really error-free, I guess Elm is a bad choice. I've been doing some on our conference website. We have this animation running, and I wanted to just try to tweak that animation and see where I could go with it, creative programming. And doing that stuff with Elm is a bit more work because it has to compile all the time, and you're a bit more constrained by the language. So if you're just making a prototype or just some creative programming, JavaScript would be my tool 10 out of 10 times. Or something else that's really, really small. And of course, if the learning curve would be too big, if the team doesn't know FP or doesn't want to learn, it's also a bad choice. So to attempt to summarize, my favorite tool in the JavaScript world is React, Redux, and perhaps TypeScript. And I feel that's in Norway, there's a lot of mountains, and we have to drill a lot of tunnels to get our trains and trams and cars through. So the traditional way to make tunnels is to just use TNT and just blow the stuff up, right? But in Europe, they're using a lot more of these things called tunnel drilling machines that take months and months and months to transport and set up. But once they're set up, they're much quicker and much safer. So I feel that React Redux is like this big tunnel machine that you have to set up. You have to learn all these frameworks. You have to get the build tool to work, and there's so much things you have to do and learn and able to do it. And that's why you have these dedicated front-end developers. Whereas I feel that Elm is more like the works out of the box. Just set it up, use the Elm architecture, use Elm format, and you're good to go. You have a great tool that will enable you to write pretty complex applications. So, it's delightful to use. I really think so. Apps are easier to maintain. It enables our team to be all fully full stack. The functional learning curve may be tough for some, but I think the following year will be really exciting to see if this catches on in Norway and in the community as a whole. So, to go back to my initial complaints with the current state of JavaScript, I really feel Elm checks off all of these. I hope I piqued your interest. If I did, please try Elm. Get in touch with the Norwegian Elm community. Join the monthly meetups. That's meetup.com/Oslo Elm Meetup. There's this dedicated Elm Slack that has this official goal of answering every question and helping every individual who wants to have help. So if you ask a question there, either on the Norway channel or on the general channel, and you don't get a response, just ping one of the high-profile Elm people, and they will direct you to someone that will help you. That's a part of the policy. And also, please follow Oslo Elm Day on Twitter if you would be interested in coming to our next edition of the conference. And lastly, but most importantly, just make something. just go to the Elm website and try the in-browser Elm compiler, where you can just fiddle around with the code, make a small app, make a small part of your app at work in Elm, see if it works for your context, and that's pretty much it. Thank you.